The reactions of the period 3 elements with water. What you're going to see here is that a lot of these reactions you have already met somewhere in the course or at GCSE, so it's almost a little bit of revision. So the first one we're going to look at is the reaction of sodium, because remember in the elements in period 3, starting at sodium, we've got sodium, magnesium, aluminium, silicon, phosphorus, sulfur and chlorine. Now the elements being P4S8 and Cl2, and we've got argon as well, but we know that noble gases are unlikely to react. So we're going to start with sodium. We're going to do the equation first. So from GCSE, group 1 metals react with water to produce the metal hydroxide, so in this case NaOH, and hydrogen gas. And we would just need to balance that equation. So we've got 1 sodium on each side, we've got 1 oxygen on each side, but at the moment we have got 3 hydrogens on the right and only 2 on the left. So if I were to half this H2 here, I would have the same amount of hydrogens on each side, 2 on each side. Now what do we observe? Well, one of the things that we would observe in this reaction is that we would get an alkaline solution formed. So sodium hydroxide is soluble. It is a strong alkali, so it has pH 12 to 14. So when you put group 1 metals in water, the Na would fizz around, fizzes on the surface, and reacts with the water, and it appears to dissolve. It's probably not appropriate to say it does dissolve. The Na fizzes on the surface, and the fizzing is the effervescence of the hydrogen, melts into a ball and forms an alkaline solution. So it kind of looks like it dissolves, but it's actually reacting to form an alkaline solution. Then when we were in the first year of our A-level course, we studied the reactions of group 2 elements, and we did magnesium with both cold water and with steam. So again, if we look at the equation first, when magnesium reacts with cold water, metals react with cold water to produce the hydroxides. So we would be getting magnesium hydroxide and hydrogen gas. And so we just need to balance this equation. And so we can see we've got 1 Mg on each side. At the moment we've got 2 O's on the right and only 1 on the left, so I'm going to put 2 in front of water. That gives us 4 hydrogens on the left, and if we add them up we've got 4 hydrogens on the right. Now, unlike the first reaction with sodium, this is an alkaline solution of the hydroxide, but remember MgOH2 is sparingly soluble. So actually, it's not all in solution. Some of it, well, most of it is still a solid. So it's only slightly soluble, sparingly soluble. So instead of having pH 12 to 14, it actually is only just alkaline, pH 8 to 10. When we look at our observations for this, we always say it's a very slow reaction. And we don't see effervescence, a few bubbles, because it's very slow. So a few bubbles are seen. So instead we could try the same reaction but using steam. And when we do this with steam, the magnesium solid reacts with the water but as a gas, steam, and it makes the oxide as a solid and hydrogen as a gas. And so we see a white solid forms of magnesium oxide. That's our MgO. What we don't see is any effervescence because there's no solutions, and we also see a bright white light. when we look at this space for aluminium, we can see that there is no reaction written. Obviously, we wouldn't have that advantage in an exam. We just need to think, why is there no reaction space here? And that is because, unlike the other metals, aluminium is coated in an insoluble Al2O3 layer. And it's the fact that that layer is insoluble that stops it from reacting. Then we can see that silicon is not reacting with water. That's because it's macromolecular. Phosphorus is not reacting with water, and sulfur is not reacting with water. And the last one we have here is chlorine reacting with water. And again, this is one from the first year. If chlorine reacts with water, we get HClO and HCl. And if we look at this equation, we can put some oxidation states on and say, well, the chlorine was 0 at the start, but in this product it's -1 because hydrogen is +1, and in this one, because hydrogen is +1 and oxygen is -2, the chlorine must be +1. And so we've got this disproportionation occurring where the same element is both oxidized and reduced. What would we actually observe? A green solution forms because chlorine gas is pale green gas is bubbled into the water, and we see a pale green solution. And then blue litmus turns red because acid forms. Both of these are acids, HCl and HClO. And then white because they bleach. The bleach being the HClO. So it's an example of disproportionation. Because chlorine is simultaneously oxidized, its number increases, its oxidation state increases from Cl2 to HClO. And reduced, its oxidation number is reduced or decreases from Cl2 to HCl. And then we have the argon, the noble gas is not reacting.